In this problem, we are given a clock, and the associated with the clock is a positive x-axis and also a positive y-axis. Let's get our coordinate system right first. Assuming that this is the circumference of the clock, we have the number 12 somewhere over here, the number 3 will be over here, 6 is over here, and 9 will be over here. Clearly, since the direction of the positive x-axis is from the number 9 to the number 3, the positive x-axis must look like this. Similarly, since the positive y-axis is directed from the number 6 to the number 12, it must look like this. Obviously, the point where the x-axis and the y-axis intersect is the center of the dial, and that must be the origin. Now the question states the velocity of the tip of the hour hand. So let's try to figure out how the tip of the hour hand actually moves. So for example, if that's the hour hand, this is the tip of the hour hand, clearly the hour hand moves in the clockwise direction, and so the tip of the hour hand would describe a circle which is concentric with the dial of the clock, like that. At any point of time, the tip of the hour hand would be at some point on the circumference of this circle. For example, it could be here, or it could be here, or it could be here, and so on. And the tip would always be moving in a direction which is tangential to the circle in the forward direction. For example, when the tip is at this point, its velocity would be directed in this way. Similarly, when the tip is over here, the forward tangent would be like that, and that would correspond to the direction of the velocity of the tip. Finally, when the tip is over here, its velocity would be directed like that. Now the first part of the question asks us to find what is the exact time when the velocity of the tip is this much. Clearly, the direction of the velocity of the tip will tell us where the tip is. For example, if the direction of the velocity of the tip is more or less in this direction, clearly it would mean that the tip is in the first quadrant, because if you look at the portion of the circle in the first quadrant, the velocity would be inclined similar to this particular velocity, and this would mean that the time is between 12 o'clock and 3 o'clock. Similarly, if the tip's velocity is in this direction or a similar direction to this, then the tip would be in the fourth quadrant, and the time would be anything between 3 and 6 o'clock. If the velocity's direction is like this or something similar to this, then the tip would be in quadrant 3, and the time would be between 6 o'clock and 9 o'clock. If the velocity's direction is like this or similar to this, then the tip would be in the second quadrant, and the time would be between 9 o'clock and 12 o'clock. Now let's try to figure out the direction of the actual velocity of the tip. The velocity is made up of two components as mentioned over here. The first component is the x component, which is minus root 3 pi I cap. So that would be in the leftward direction because of the minus sign, and the magnitude of this component is root 3 times pi centimeters per hour. The second component of the velocity is the y component, which is minus pi j cap centimeters per hour, and because of the minus sign, this velocity component must be in the downward direction. So I draw this velocity component like this. It's in the downward direction, and its magnitude is pi centimeters per hour, and since the total velocity is the sum of these two vector components, I can apply the triangle law and I can draw the actual velocity of the tip like this. This is V bar, and since the general direction of V bar corresponds to this direction, we can conclude that the time is somewhere between 3 and 6 o'clock. Now we have to find what is the exact time. To find the exact time, we have to find the exact direction of V bar. If you look at this particular triangle, you notice it's a right angle triangle where this is the right angle, and let us say that I call this angle theta, which I want to find. Now in this right angle triangle, clearly tan theta is pi divided by root 3 pi, which would of course be 1 upon root 3, and that gives us the value of theta to be 30 degrees. Now we know that the leftward direction in the figure corresponds to the negative x-axis, and so at the given time in the question we can state that the condition is the velocity V bar of the hour hand's tip must be directed at an angle of 30 degrees below the negative x-axis. Let us now go back to the clock and see what is the exact time when this particular condition is satisfied. Let us imagine that the hour hand is in some position like this, and this is the tip of the hour hand. Clearly the hour hand's tip moves in a direction like this, and if I draw this line segment in the negative x direction, then I know that it is this particular angle which should be 30 degrees. Now we will attempt to find this angle, because it is this angle which is currently unknown which will tell us the exact time. For example, if this angle were to be 0 degrees, then the hour hand would be pointing towards the number 6, which would mean it is 6 o'clock. To find this angle, we will have to apply a bit of geometry. Notice that the hour hand is the radius of this circle, and this arrow corresponding to the velocity is along the tangential direction. Now we are aware that the radius will always be perpendicular to the tangent. In other words, this angle has to be 90 degrees. If that is the case, then clearly this angle must be the complementary angle of 30 degrees, and so the value of this angle must be 60 degrees. Now we observe that this particular triangle is a right angled triangle in which this angle is 90 degrees and this angle is 60 degrees. So clearly the remaining angle, that is the angle at the top, this one, has to be the complementary angle of 60 degrees, which is 30 degrees. Now all that remains is to find the exact time. To do this, we mark the other numbers on the clock between 3 and 6. I'll put 4 somewhere over here and 5 somewhere over here. Now if I join the center of the dial, that is O, to the number 4, and similarly I join the center of the dial, that is O, to the number 5, I realize that the angle between the number 3 and 4, that is this angle, must be congruent to this angle, and that must be congruent to the remaining angle, that is the angle between 5 and 6. Also, the sum of these angles is 90 degrees, and hence each of these three angles must be 30 degrees. So this angle is 30 degrees, and so is this angle, and so is this angle. Conversely, when this particular angle is 30 degrees, as we have just found out, in this problem, the hour hand must definitely point in the direction of the number 5, and naturally the conclusion is that the time must be 5 am, or the second possibility is it is 5 pm. Finally, we have to find what is the length of the hour hand. In other words, if I mark the tip of the hour hand as point P, then we have to find what is length OP. To do so, we will find the speed of point P by two different methods, and we will then equate the speeds obtained by these two methods. In the first method, the speed is got by taking the modulus of the velocity given in the question. So that would be modulus of minus root 3 pi I cap minus pi j cap centimeters per hour. Now that would be under root of root 3 pi the whole square plus pi square centimeter per hour, and that would be 2 pi centimeters per hour. Now we evaluate the speed of point P by another method. We realize that point P is moving along a circle, namely this particular circle, and it completes one circle in a time of 12 hours. Clearly, the speed of point P would be the circumference of the circle divided by the time taken to complete the journey, which is 12 hours. And of course, the circumference is 2 pi r, where r is the radius of the circle, and this has to be divided by 12 hours. But notice that the radius of the circle is nothing but length OP, which is the length of the hour hand. So here I write 2 pi multiplied by length OP divided by 12 hours. Now of course I equate the speed of the point P obtained by these two different methods, and so I obtain 2 pi into length OP divided by 12 hours equals 2 pi centimeters per hour. And finally, solving this equation, we get length OP, which is the length of the hour hand, equals 12 centimeters.